I'm here to share with you another calculus video. This one is from the practice that you worked on today. That says on the top of it, Chapter 3, Section 4, Problems. You did 6 questions on motion. A really nice, thorough look at most of what you'll see for motion questions in calculus. And I had several questions about number 6. So, without further ado, I'll do my usual. I'll show you number 6, all of the work I wrote out, and then I will talk about things. If you need more time with anything I show, remember you can pause the video at your leisure to review what you're looking at. So here's the next part. And then this part from D all the way to the end. Okay, now I'm going to talk a bit. So our function is y of t, and in the problem it says you're moving along the y-axis. So something that's different here is we're moving up and down instead of left and right. In part A, we are asked to find the position at the time of 0. That means I need the output of the position function when t is 0. That's 3 feet. Make sure you have correct units on there. If you don't have correct units, you would not get the answer point. Letter B, we're asked to find the velocity function. Now, one key detail I want you to make sure you pay attention to is I've identified this new function velocity, but I've connected it to the function y prime of t. To get the derivative, I need the product rule, which I've spelled out here. Derivative of cosine, the derivative of 2, I simplified. Letter C is very interesting in terms of the work that I did, because you look at it and that may not make sense to you. You might think to yourself, why on earth are we determining when the velocity is 0? Well, that's because when we're talking about motion being at rest, we're talking about the sign of the velocity, which is no sign, 0. Or negative left, or positive right. That's for horizontal. For vertical, it's 0 again, no motion. Negative is down, positive is up. So we want to answer the question about when is the particle moving up. But in order to answer that, we actually look at all of the different motions for all of the different time intervals, which are described by the resting points for the particle's motion, or when the velocity is 0. So this is something that feels very weird. In order to answer the question we're asked, we have to answer something different. So we do that. And I chose to do this without a calculator, but you can definitely do it with a calculator. The reason why is because I wanted to talk about how I can solve this with factoring, namely, as this equation equals 0, either t is 0 or cosine of t is 0. And then I did the interval from 0 to 5, even though it didn't spell it out very well in the directions, but that's what it asks for later on. And I divided up my motion interval from 0 to 5 into the interval from 0 to pi over 2, pi over 2 to 3 pi over 2, and 3 pi over 2 to 5. And then you have two options here. If you have a calculator, you can substitute values in or look at the graph. When the graph is above the horizontal axis, we're moving up because it's positive. When the graph is below, we're moving down because the sign is negative. When we're moving up again, that's because the sign is positive. The other thing you could do is you could choose a representative value between 0 and pi over 2, substitute it into the velocity function, and determine the sign. We don't actually care about the value, we only care about the sign. Remember, we're talking about vectors, and vectors have both magnitude, which is the value of the number, as well as direction, which is what the sign tells us. And we're only interested in the direction here. So, from this analysis, we know that from 0 to pi over 2 and 3 pi over 2, the particle is moving up because the velocity is positive. Letter D, we take the derivative of the velocity, which is the second derivative. Again, I need the product rule. Derivative of t cosine of t, derivative of cosine first and t second. A little bit of simplification. Letter E, I used my knowledge from part C to remember that we found when the velocity was 0 or the particle is at rest at pi over 2 and 3 pi over 2. The first of those or smallest of those is pi over 2. I did it without a calculator and with a calculator. Again, notice the units. Letter F is the last one. Letter F is again drawing upon the work we did in part C, because when you're talking about total distance, you want to make sure you're paying attention to the direction of motion. Because if you just look at displacement from one point to another, all it's going to tell you is how far apart those two positions are. It's not going to tell you how far you went between those. For example, if you have a stopping point and then you turn around and then you stop again and turn around, your distance is going to get hidden by all of that. So from pi over 2 to 0, that's one displacement. From 3 pi over 2 to pi over 2, that's a second displacement. And then from 3 pi over 2 to 5, that's a third displacement. I add all those together, making sure this one stays positive, and I get 7.055 feet, which is different from the answer key. The answer key is off by a digit. Thanks for listening to another calculus video from yours truly. Remember to smash that like and subscribe button. See you next time.